Okay, ladies and gentlemen, this video is about finding inverses. So here would be a typical problem, let's say, on a Common Core or state test. Notice what it asks you to do is, hey, can you find g inverse of x? In other words, can you find the inverse of g of x right here? Well, hopefully we're pretty familiar with the procedure. And here we go. Would we not, first of all, our first step, would that not be to take g of x? Remember, g of x is another name for y. Or another name for y. So wouldn't we call that the x? And the x there we'll call y. Okay. So that's a 3 right there. Okay, so notice, guys, again, I switched the x and y because once I have an equation that goes backwards, with x and y switch, it does go backwards, I hope you agree, then I will have logically the inverse function. So we're going to solve for the y now. So hopefully you agree we would add 9 to both sides. And therefore I know x plus 9 would equal 3/5 of y, because 9 minus 9 is 0, right? Now, do you guys remember how to get rid of the fraction 3/5 timesing y? How about if we use the reciprocal 5/3? So I'm going to times both sides by 5/3, okay? Now what's that going to do is, of course, notice on the right side, isn't 3 divided by 3, 1, 5 divided by 5, 1. So notice I do get my result, y equals 5/3 x plus 9. Now look at our answers over here, and you'll notice, they still look a little different. Why is that? Well, didn't they do the distributive property? So the next thing we got to do, of course, is 5/3 times x. So we'll have 5/3 x, then 5/3 times 9, which is 45/3. 45/3. Because 5 times 9 is 45, right? And isn't 45/3, this right here, 15? So notice I now know my g inverse of x has to be 5/3 of x plus 15. And somehow we have the sign wrong, because I do not see it there anywhere. Wow, could they have possibly made a mistake, or did I make a mistake? Because I see a minus 15. We did plus 9, which is correct. I think we stumbled upon a bad problem, ladies and gentlemen. Unless I am mistaking somewhere, which I am not. So guys, guess what? There is no correct answer for this problem. So I guess when we come across it in class over the next couple of days, we'll have to remember to double check it. But anyways, let's continue on with the lesson. Wow, I can't believe I just found a bad problem on my computer system. Anyways, let's keep going here. Now, here's another concept we really haven't talked about much. Can we solve all of these power equations here? And getting straight to the point here, how do I solve an x squared? Well, can't I do a square root of both sides? Because the square root will cancel out the square power, right? And am I not left with x equal to 4? And technically it's positive or negative 4. But anyways, does everybody agree the square root of 16 is 4? So how do you get rid of a square? We square root. Okay, how do we get rid of a cube power? Well, hopefully you're thinking we're going to cube root both sides. So x this time is going to equal the cube root of 27 there, which I hope you realize is 3, since 3 times 3 times 3 is 27. And it took 3 3s to make it. Alright? So how about the last problem here? How would we solve a fourth power? How would we get it to x? Now hopefully you realize, I'm just going to do another radical. This time I'm going to do a fourth root. So without simplifying, guys, I know the 4th root of 4 cancels out. I'm just left with x equal to whatever the 4th root of 50 is. Now, normally we would do this right here on our calculator, okay? But to save time on the video, let's go ahead and save that for class time. But x would have to be the 4th root of 50. Now, the reason why I brought that up, guys, is look at the next problem. Here, notice, they gave us f of x equals 3x squared. And they want us to find the inverse. Okay, so hopefully by now you realize I'm going to put x in for f of x. I'm going to put y in for the x. Again, see how I switch my x and y's here. And now my equation is backwards, so I'm going to solve my backwards equation, which gives us the inverse, right? So what would I do next? How about if we divide by 3 both sides? And now we're left with x over 3, or x divided by 3, equal to 3 divided by 3 is 1, right? Y squared. And so now you can see right here, oh, how do I solve for y squared? Well, how did we solve for it right here? Right? Did we not, to get rid of the square, do a square root? So all we have to do, guys, is do the square root of both sides. So hopefully you agree over here, y will be the square root of whatever x over 3 is. The square root of x over 3. Now, there's ways we can simplify that, guys. But for now, let's just leave it as such. And I would give you full credit for that, okay? Because we haven't gone into in-depth simplifying of radicals with denominators and stuff yet. Okay? So now what? Well, let's take a look at this problem right here. Last problem, guys. If you look over here, they want h inverse of x. And how do we solve that? Well, again, when we start out with calling the y part, h of x is y, so we would call that the x. And the x here will become a y, right? So we'll have y cubed plus 8 over 7. Now, solving this, hopefully you agree, I'm first going to times by 7 both sides. 7 divided by 7 is 1. So notice 7x now equals y cubed plus 8. What would be next, guys? That's right, we're going to minus 8 both sides. So 7x minus 8 equals y cubed. And so where did we go from here? Well, just like I showed you here, how do we right here solve for the y, or the x cubed in this case? We would do a cube root to get rid of a cube power, right? So with this y cubed here, let's go ahead and do a cube root on the y. And the cube root cancels out 3. So my inverse is simply right here, guys, the cube root of 7x minus 8. And what do you know? It's answer C, isn't it? So anyways, guys, that ends our video. Sorry for the one mistake there. I have to be surprised. I'm going to have to redo that with you in class just to make sure it is a bad problem. And maybe I made a mistake. We're all human beings after all. But guys, hopefully you'll watch this video and it all makes sense to you. So until I see you next time, bye.